Okay, today we're going to first I'd like to do a demo. The demo is a Sonic Pi. I found Sonic Pi is so interesting and so much potential. So I will give you guys a demo. Hopefully, you guys was excited and maybe do a project on it. So let's go to my Sonic Pi. I will connect to my Raspberry Pi and then I share my Pi with you with the demo. Now my Pi is shared. I will just go right to Sonic Pi. Basically, you can compose any music. Sky is the limit, literally. Any type of music you like. Your creativity is endless with this music synthesizer. Basically, the music is created by your computer. Yeah, this pandemic, we didn't go anywhere. We didn't even leave Shenzhou. Didn't even leave my house for many months. I just
That's true.
in its bedroom.
Well, we would have never taken this trip if this didn't happen because we were planning on going to Florida back in May.
Yeah,
But then all this stuff started happening and we didn't end up doing it.
yeah. Wow, that's
My pie is faster than your pie.
okay. Right now, finally. So this is a couple of demos. Let's start it with they each has a buffer. So how to play this? I forgot how to play. Oh, here. Did you hear anything?
No.
Yeah, I didn't hear anything either.
I was testing it earlier and I couldn't hear anything either, so I don't know.
Let's
I did
see.
it, and I was able. Well, on mine, I was able to hear it.
Really?
Yeah, I mean,
Did you have did you set up like a speaker to it or something or what?
no, I have my plugged into a TV, so I just put the volume up.
Oh, to a TV.
Yeah.
Yeah, I plug in TV. It's here. Let me. Yeah, I heard it on TV also, but I try to make it work here.
On your monitor?
Yeah.
Maybe it doesn't work with monitors.
Yeah, that's right. You're probably right.
Because
Yeah.
I plugged in like a small speaker to my Pi, but still wouldn't make a sound.
Yeah, it doesn't work with monitor. It just images. So I will probably just play it on my TV, and hopefully my mic will pick up.
Where did you get that code from?
I downloaded from Google search.
Started up, it has what's it called? Like sample codes that you can put on there.
Which book?
No, it's already in there.
It's already in the
Tutorial.
The Sonic Pi tutorial. It's on there.
Yeah.
It'll just show you to copy and paste it.
that's one. That's the second one. That's the third one. This is the last one. So let's give you an idea. So this thing can play some music. Last semester, one of our graduates did a similar thing with a Sony Pi. Let me close that sharing. So you guys did hear the music, right? Okay.
Yeah.
Okay. Now we move to the second textbook we're going to use. Second book. The second book is Mastering the Raspberry Pi, which is a more substantial Pi book. The first book is an excellent start. The second one will be a good way if you want to know a little bit more.
Is that on Canvas?
Yes, it's on Canvas. It's on the
I don't
download
see it.
file. You go to the Canvas, go to the file, and
Wait.
I have a bunch of files. So this book from chapter 1 to chapter 10 is the introduction of Raspberry Pis. So it talks about the various parts of Raspberry Pi. It started with the introduction of Raspberry Pi, preparation of Raspberry Pi. We have already done this because the first book, introduction, already covers this topic. And then I talk about the power. When we talk about power, one thing I want to mention for this part is how to use the battery to power our Raspberry Pi. So here, the author has a very good section, started here, battery power. So if you want to do a project, Raspberry Pi battery powered, you want to read this material. Most importantly, Raspberry Pi need a positive 5. So your battery may be 6 or 8.4. So your battery will be not perfect 5. How do you get perfect 5? There's 2 ways to get the 5 out of your battery. Method number 1 is use this regulator to regulate voltage. Output is 5. This is a good way, but not the best way because the efficiency problem. This is 7805. What happens is this will be a big resistor. This resistor will took out the power from battery, so your Raspberry Pi only has 5. So efficiency is low, very low. This is not recommended unless you have your battery is strong, you have a big strong battery. You don't worry about the efficiency. Alternatively, a better choice will be this buck converter. Buck converter is perfect because it can be above 90% efficiency when down converting from whatever 20 or 10 to 5. You have over 90% efficiency. Unlike the previous one, usually it's 50% efficiency. That means half the energy goes to your Raspberry Pi, the other half burned out on your regulator, wasted. Can be so this is a buck converter. Buck converter is I actually did a simulation last semester for a buck converter. It's an excellent way of down converting DC-DC. So high voltage goes to low voltage, 90% efficiency. Why? Because we are switching instead of previous case is put a resistor in between the load. If you put a resistor right before the load, you're wasting energy. This particular one, we are switching the power to the load instead of put a resistor. So a buck converter is also inexpensive, almost same price as the previous case. So you can buy one of those. The author bought those, I think, from eBay. You can Google it. It says $1. So this $1, $1.5. So very inexpensive, and of course that's the way to go. Do not use the first method if you use battery because you're wasting energy. So now we got this buck converter DC-DC. It's excellent. So you double your battery life in a wireless scenario. Anybody want to do a battery powered project? Jermaine, you are still thinking about that the deer can?
No, probably not.
Oh.
I think I'll switch something else.
Yeah, the deer will probably destroy it. They know the camera.
Yeah.
Not deer. All right, that's a battery buck converter. The next topic, we'll go through the first 10 chapters really quick because the first 10 chapters kind of overlaid with our first book. And there is some new information, so I will point out those new information as we go through. And then they talk about the headers, LEDs. We already go through all those, so I just pass. GPIOs, the headers, the pins. And you can add a reset. If you notice, the Raspberry Pi do not have reset. You can add if you want it. You have to solder two jumpers, two wires right here, I guess right here. So those are the reset. It's not, there's no anything over there, so there's no reset. But you can add a reset with a push button. So this is a reset circuit. I always sometimes like to have a reset because when Raspberry Pi gets stuck, instead of unplug the power, you just push the reset button. That's much better. So that's chapter 5. The only thing new is add a reset if you want it. Now we look at the memories. This is a command line. You can find information about the memory of your Raspberry Pi. So if you type that on your Raspberry Pi, I will do that now on my Raspberry Pi. I will log in to my Raspberry Pi. I will have a share of Raspberry Pi. now you may realize the terminal is probably the best way to deal with Raspberry Pi, because the terminal need very little resource. The graphic interface is nice, but the graphic interface is for not for engineers, right? We are above the graphic interface. We don't use graphic interface. We use this terminal. With terminal, you can control pretty much everything you want to control on your Raspberry Pi. So I will log in, not this one. I log into the wrong one, but it's okay. Wrong one. So I can type this command. What is that command? Okay, memory info. Okay. I tell you everything about the memories, total amount of memory. I have 1G. If you buy 4G, excellent. You'll have a much more powerful computer. So the author goes through every little detail of each of those, which a lot of information, but I will skip, maybe unnecessary. But what we interested more is the free memory. I only have 200 mega left. So I really need more memory. So if you have a newer Raspberry Pi, it's good because, wait, I will close my Sonic Pi to see how much free memory I will got if I close this. Now I close my Sonic Pi. I will redo the same command. Let's see. Now, I still have the same amount of free memory. Memory available. 600 memory available. Let's see previous. Previously, memory available 600.
Overcoming sexual sin, because I know how tough it is. You know what I'm saying?
Artura.
Yeah, that stuff is difficult to overcome. I know how tough it is.
Keep speaking. So it tells you a little bit of information about all the memories. If you are interested in memories, you want to dig into it. Find another thing I find interesting about memory is the memory map. When we look at a computer, we're always interested in the organization of memory map. So let's look at the memory map. So this is the memory map. Let me go to the shared. So this is the memory map of your Raspberry Pi. Its started location is all zeros. And it's 64-bit. So Raspberry Pi is the processor is similar to the desktops, PCs, 64-bit. So this, if I have 1G memory, that will be my 1G. If I have 2G, then I will double amount of memory. Notice the memory is shared with a GPU. So GPU and main memory, they share the same 1G memory. So right now on my computer, I have 64 mega as GPU memory. But I found out that 64 mega as GPU memory is not enough for if I'm watching, for example, webcams, Yellowstone webcams. It's kind of slow. So I doubled that. After I doubled it, it runs smoother, much smoother. So if you're running more graphic applications, you need to increase your GPU memory.
Wait, how did you do that?
Yeah, how do you do that? You do this. You do rasp config. Maybe add sudo rasp config, and then you go to the.
I don't see anything.
Oh, all right. Thank you for the feedback. I will share that terminal. So you type this sudo rasp config, and then you go to this memory part. You can allocate graphic memory, more graphic memories.
Okay, wait, so now what?
You can also overclock your CPU. That's our next topic.
Oh, I see it.
Yeah. To overclock your CPU,
I don't see
you
anything.
sudo rasp config. Yes.
Wait, but where's the RAM? Or not the RAM? The memory.
Yeah, you go to the advanced option maybe.
Oh, okay.
Memory split. Yeah. How much memory? 64 right now. So I can change it to, yeah, more. You see, I'm moving my marker towards more.
Wait, so you went to advanced options, but now, memory split, you said?
Yes, memory split. Yeah.
Mine says 128. Oh, it can go to 256.
Oh, you have a better Raspberry Pi, so you're already 256. Yeah, because you have a more memory. Your Raspberry
Mine
Pi.
won't let me over. It says only Pi 1 or Pi 2 can be overclocked with this tool. There was an error running option 6 overclock.
Yes, you cannot overclock on this program. Okay, I have to correct myself.
Wait, but we're not overclock. We're going for the memory.
Right now it's memory, but the next topic will be overclocking. So chapter 7 will be CPUs. We'll talk about CPU and potentially overclock your. Let's switch back to my document. So this is memory. A lot of topics, virtual memory, that's a subject. The next chapter will be CPU. And depend on your Raspberry Pi, you have different CPUs. So this is how you find the information on your CPU. All you do is type this command, cat. So open up your terminal and type this. So what did you find out, your CPU? ARM processor revision. Can anybody read out your output?
I had to reboot mine.
Mine
Yeah.
is an ARM v7 processor.
Oh, wow. You have a.
Yeah, mine says the same thing.
Okay, you have a Raspberry Pi 4, right?
Yeah.
Okay.
Yeah.
So it has a serial number, and all the processor. So next topic will be the overclocking. The overclocking of Raspberry 4, I don't know how to do 4 because I don't have a 4, but I have a 3. For 3 overclock, anyway, it's very easy to overclock. If you want to overclock 4, all you need to do is Google overclock 4. For 3, it's re-editing one of those configuration files and then reboot. And it's a good idea. I actually watched a YouTube video. A guy did a YouTube video on overclocking. Excellent YouTube video. What he did is he will overclock and then he will benchmark. He will basically stress test his CPU. He put a benchmark code stress testing the CPU for at least 10 minutes. Make sure everything, the CPU not overheating, CPU is working properly. If the CPU is not working properly, it will crash. And then you have to, in extreme case, you have to unplug your SD card, plug it into your computer, change back to not overclocking and replug it in because your computer is crash every time you turn the Raspberry Pi on because you're overclocking too much. General idea is you can overclock 200 megahertz or 300 megahertz without problem. Why? That is because the manufacturer, when they make the chip, they make a batch of those. They try to make the fastest speed. They don't make a 1G version or 2G version. They make as fast as they could. But because the manufacturing process, not every chip are created equal. So some can run faster than others. So pretty much the manufacturer just do a safety test and put 1G because they can guarantee every chip runs at 1G. But if you're lucky, your chip may be run at twice the speed, no problem. But some people may not be lucky, their chip cannot be overclocked. So if you see somebody can overclock with no problem, it doesn't mean your computer can do the same thing because every Raspberry Pi, every CPU chip is created differently, the manufacturing process. So you can overclock, but good luck with that. You also definitely need a heatsink attached to the processor. Why do you overclocking? Speed. You play video games, you want speed. Also, you want to watch videos. When I was watching YouTube videos, my Raspberry Pi 3 cannot do it. It just freeze and not quick enough. So that may be another reason to overclock. There are some overclock settings which will void the warranty of your processor. I don't even know the processor has warranty. So anyway, there are some settings. If you cross the limits, the CPU will permanently change flag inside, and there's no way back. So if your processor ever goes wrong, you want warranty repair, the manufacturer will check that and say, hey, you did this, you voided your warranty. So there are many different subjects about this overclocking. Generally, you already have the most expensive Pi, the latest Pi. I don't think you need overclocking for any reason. For academic research purpose, maybe, yeah, we can do it. Try it if you're experimenting. So any questions with that overclocking? So we move really quickly to our next topic. Next topic will be the USB chapter 8. So this USB Raspberry Pi 4, you even have the USB 3. So for Raspberry Pi 3, only the older USB. So anyway, USB is very, very useful. My Raspberry Pi USB port is always used. There's four of those USB ports. So if you do a project like a network drive, you can plug in a hard drive and use your hard drive around your house as a storage, so as a central storage device. So everybody share the single hard drive. I did this. That is something I did a couple years ago. I'm using this almost daily. So my files, if I think about the pictures, I'll put it in the central location so everybody can see it around my house. So that's a good project to do a Raspberry Pi network storage. Anybody interested in that? I think last year a couple of students did that. They put a network storage drive around their house. There are different ways.
Movies and music and stuff there?
Yeah, music, movies, pictures, documents. Yeah.
That sounds like it could be useful.
Yes.
Wait, how would you get started again?
How do you get started on the network drive?
Yeah.
There are many ways. The one I did is called I forgot. Let me check how I did it. It's on the project. The Word document I provided the list of all the projects.
Right.
One of those will be the network drive.
Okay.
It's called Open Media.
Oh.
NAS using Open Media. So you have a network storage device. Network NAS means a network. What is A? Accessible, network accessible storage. It can be Wi-Fi, wireless, so you put your drive anywhere you want it. A word of caution is the bandwidth problem. A Raspberry Pi 4 is good. Raspberry Pi 3 is terrible because everything share one tiny bandwidth. The Wi-Fi, the Ethernet, the USB. So it's very congested highway. So if you're using Raspberry Pi 3, don't do it. I use Raspberry Pi 3. The speed is so slow, your hard drive. So if you want to put a movie or music to the hard drive, it takes very long time. Raspberry Pi 4 has a gigahertz Ethernet, so I would recommend you plug in to the Ethernet with wired network. And then you can do a benchmark of how fast the hard drive goes. I would say it would be really fast, much better than Pi 3.
Well, how would you do the benchmark then?
I would say you have 1 gigabyte file, you just copy to your hard drive to see how fast it finishes.
Oh, so there's a file to do that?
You just download the movie or whatever, 1 gigabyte, yeah.
Oh, okay.
Yeah, you just testing it using a large file. You do a copy.
I thought you meant like there's a tool to see, all that
yes,
stuff.
they might have tools also, but yeah, I just use the simple one. I find a large file.
Okay.
Like my recording, usually my class recording is close to 500 mega. After I ended the class, I have 500 megabytes. video file, if I want to test the speed, I just copy it to my hard drive to see, take 1 minute or 2 minutes to finish, and get an idea how fast that thing is running. Yeah, that's not a very accurate way. So Jeremy, you made interesting. You're looking for benchmarking. There are tons of benchmarking programs available. Testing the internet speed, testing your CPU speed, testing the hard drive speed, memory speed. So when you're testing the hard drive speed, you point the hard drive to your network hard drive, and that you're testing the network hard drive speed. Yeah. Yeah, that's a good question. We might do some research after class, find out a better benchmark program on different platforms. So that is Ethernet. There are a lot of technical details on everything. But many times we don't have time to dig in. So if you do a project really on something, you might dig in to one particular area. And once you spend a couple hours study the subject, you become the expert pretty much in that area. So for example, the little bit more information about the Ethernet. But I haven't read that much detail. So this is what we have here is how you find your Ethernet address, ifconfig. We have been using this repeatedly many times, ifconfig. The last chapter, chapter 10, is SD storage, SD card. The SD card uses SPI, a serial, so one single wire or 4 wires. They are serial communication. So it's all the SD card has the same interface. So that's when you take a digital camera, when you take a picture, your picture it would be putting inside the SD card. Same thing happens here. We use the SD card as if it's our hard drive. So obviously you want this type of SD card, high capacity, and also high speed. Why? Because the data bus is 4-bit. So minimum, you want this. So if you use the old one, data bus is 1 bit, and you upgrade to a 4-bit, you notice the difference 4 times, at least 4 times faster. That's a huge improve. So you want SDHC, or even better, HDXC. I have this latest. I would think it has an 8-bit data bus, 8-bit. I'm not completely sure. I think my newest is 8-bit because this newest SD card has more connectors, doubled amount of connectors as this 4-bit. So this SD card technology is still evolving. So at minimum, you want HC. I would assume everybody got that because when you buy the latest model, they probably would give you. Okay, if it's over 2 gigabytes, it's HC. That's no problem. Everybody has 2 gigabytes above. So 4-bit, that's much faster. 4-bit. It's SPI. We will talk about SPI next week. SPI is the serial interface. We will also do a demo on SPI. So this is pretty much the last topic is very leveling. It turned out the SD card can only write, for example, 1,000 cycles or 2,000 cycles. So obviously, you do not want to write the same spot repeatedly. You want to level, you want to average it out. So you want to write your data at different locations. So you get a longer life. It's kind of like the battery balancing. When you charge your battery, electric cars or electric vehicles, bicycles, ideally, you want to have an extra module on your battery pack that is called the battery balancing. They will balance out all the batteries, so every battery will be charged differently, a little bit differently, to maximize performance. Same thing here, the SD card, we're leveling. It will rotate the SD card write area. So your SD card will last longer. If you do not rotate, you ended up right on the same spot, and you burn up one spot, and basically the whole SD card is wasted. So that's the first 10 chapters. I go through it really quickly, pointed out some areas which are interesting to us. I will move on one more subject, which will be the UART. UART is the oldest technology. It goes back 50 years, so older than me, even. So this technology is still being used today. I have a couple of UART on my. So we're still using this technology, UART. Serial UART. It's a 2-wire. So you have a 2-wire to communicate. It's a serial 2-wire. If you include the ground, it's 3-wire. So you have a receiving wire, you have a transmitting wire, then you have a ground. So minimum is 3. And it's old technology. It's actually pretty complicated. There's a lot of details, And usually it works without any trouble. If it doesn't work, it's became a huge headache. I've been working on this, and if it doesn't work, sometimes give you a huge headache. But fortunately, most time it works. You just plug in and everything. I will give you a demo about the UART or serial. The demo will be. Let me go through all the pages. Okay, now we move to the demo. So I will open up this equipment panel. And then I will share my equipment. Device failed. Oh my, what's wrong? All right, my equipment is up and running. Let me share it with you. I really like this. I use it every day for lecturing. It's a perfect way to give demos because it has all the instruments. It's actually real instrument. It's not a computer simulation. It's a real instrument. But the only difference is the output is on the computer monitor, so I can share. So we can see all the instrument, oscilloscope, wave generator. Some are simple, some are very complicated. Oh. I don't know, maybe I need to close some programs. My computer is an old computer. Is struggling right now, struggling to work. So I will close a bunch of programs to make my computer happier. I will turn off this also. Okay. I have too many programs running simultaneously on my 10-year-old computer. Okay, maybe now it's good enough. So what I'm going to do is I will create a serial. I will create a serial. So I will go to my logic analyzer. Yeah, protocol analyzer. So I will open up. Oh, it's so slow. I have to close more program maybe. So this is my protocol analyzer. So I have a couple of protocols I can actually analyze. The SPI, I2C, they are all serial. So we started with the first one. So what I'm going to do is I will send out letter H, for example, letter H. So every time I click that send, I will send out letter H through my serial. And what I'm going to do is I reroute that signal to the oscilloscope. So my oscilloscope will catch what's going on. So I will say my oscilloscope, I will have my trigger, I have my trigger at 1. So I will turn on the oscilloscope and waiting for my serial to send a signal to the oscilloscope. So I'll go to the protocol, I will send, okay, I catch it. So now I'm having the serial. So this is what happened if I'm sending letter H through UART. This is what's going on. So it's so every time you want to send the letter H, that's a letter H. It's an ASCII code. So what is the ASCII code of letter H? Let me write it down. Let me put it on my camera. I will change the camera. So everybody see my camera here? Let me see the camera. Letter H, that's the ASCII code for letter H.
There's a glare.
Yeah, unfortunately. Zero 1 1 0 1 0 0 0. So that's letter H. So this is 0. I'm pointing to the 0 right now. This is the first 0. So it's sending out backwards, So the most significant bit came out last. This is the 0, 1, 1, 0, 1, 0, 0, 0, 3 zeros. So that's letter H right here. See? ASCII code 0, 1, 1, 0, 1, 0, 0, 0. Let me put a book right in front of it. Stop that glare. Now it's better?
Yeah.
So the letter H, 0, 1, 1, 0, 1, 0, 0, 0. So that's 0, 1, 1, 0, 1, 0, 0. How about I send 2 letters? Let's say the HE. I will go to my protocol. I will add another letter E. And I go to my scope. I will re-trigger it. So I will send it, and my scope will capture that. So this is H and E. So now we got 2 letters, H and E. The first one is H. It started here. That's where the H started. Where does the E started? The E started here. So E started here. So this is letter E. 0, 1, 1, 0, 0, 1, 0, 1. That's E. Notice after E, the H started here. So there is in between H and E, this is in between. They added this signal. So this added one is called the stop bit. Stop and start. So right here, we have a stop and a start. So this is how the protocol is designed. Between the 2 letters, you have a stop and start. The high voltage here is called stop. The low is called start. So H and E, stop and start. So if I have more letters, I will have more of those stop and start in between. So let's see what happens. Hello, I type 3 letters, 5 letters. So I will rearm my oscilloscope, and then I will go to my protocol, and I will send the 5 letters. Now the 5 letters is cached here. 5 letters. So this will be the O. So O will be 0, 1, maybe not complete capture. We will do the capture again. Probably we're missing something. We will redo the capture. Arm it and go to protocol, resend. Okay, now we got the complete capture. So this is the O. It started here. The O will be 0, 1, 1, 0, followed by 4 ones, 1, 1, 1, 1. You might have a question, how do you know we have 4 ones here? It's all about the protocol. The protocol says, I will transmit 9,600 bits per second. So my computer knows, because I have 9,600, I know this is 1, 2, 3, 4 ones. So ended here will be letter O. What is here is the stop and start. So these are now letters, stop and start. And then followed by L. This is the stop and start. And followed by another L. This is stop and start. Followed by E. Stop and start, followed by H. So we have 1, 2, 3, 4, 5 letters. And in between the letter, we have a stop and start for every letter in between the two letters. So every letter is 8-bit. Then every character is 8-bit. Then you plus 2 extra. That means 10-bit. So if you want to send out 5 characters, you have to send out 50-bit. So from start to finish, you have 50 zeros and ones from here to here, ended here. 50
Is there a different code for like a lowercase letter?
Yes, excellent question. That's this is a high. This is actually lowercase. That's changed to a higher case. Yeah, it's different code. That changed it to high. The actually code high low are different. That's rearm my scope. Rearm it. And that's send it out. Captured, and yeah, it's different. For example, this H, it's different from previously. If you remember previously, it's a different code. Zero, 1, 0, 0. You see, previously it's 0, 1, 1 for the O. Now it's 0, 1, 0, 0, 1, 1, 1, 1. So in this case, this 1, it was 1, now it became 0. So I think that's the difference between capital and small letters. The third bit changed from 1 to 0. 1, 2, 3, the third is 0. If you look at H's, same thing happens here. 1, 2, 3, the third bit changed to 0. So this is 0, third bit. So all capital, that means the third bit changed to 0. Let me use my pen. If you change to capital, the only thing changes is here. This guy changed to 0, the third bit. 0, 0, 0, 0, 0.
What if the third bit is a 0, then it changes to a 1?
All the small letters third bit are 1. Yeah. There's only 26 letters, so we can do that. So that's how serial works. It just pump out 0 ones, take turns. In this case, it's backwards. First, it's pumping out 0 ones in backwards. Second, so when you type hello, O came out first. This is letter O, came out first. So O, the text we send out is HELLO, but when we send it out, the O came out first. And then in between letters, you have stop and start. Stop and start. How about the others? I squared C, SPI, they are similar. They are similar. We will do a SPI demo next week when we met. All right, that's all I have. This oscilloscope is also extremely helpful because it can capture a single track with a trigger. So that's the trigger. Once they triggered, it will store, it will capture. So we only send out once, one time, and this oscilloscope will catch that event as it happens.
You better not save any more stuff.
Yeah. So similar USB oscilloscope. This if you noticed when I do the demo, we are sending out 9,000 characters per second. So that's really slow in today's standard. Today, when we talk about serial communication, we talk about hundreds of millions, 0 ones every second. The latest one. The HDMI is also serial. So when you plug in your television to your Raspberry Pi, it's computer talking to another computer through serial. The Raspberry Pi will pump out all the screen information, and your television will receive all the serial data and put it on the screen. And it's a two-way communication. If you don't know, your TV can talk back to your Raspberry Pi, and also your Raspberry Pi can control your TV. Your Raspberry Pi can turn your TV on and off, can increase and decrease the volume. Last winter, when I left home for out of town, I actually did one project. I spent almost a whole day did that project. That is Raspberry Pi video, two-way video. Raspberry Pi connect to television, two-way video with my cat. So I can remotely turn the television on and start a camera, and I can talk and can see my cat if the cat is right in front of the TV. And my cat can also see me, so it's two-way video. So after I see my cat is okay, I can turn off the television, shut everything down, all using HDMI, control the television. So that is one thing. That is actually a project somebody did, so he can talk to his grandfather. So his grandfather don't have to touch a remote, do anything. He control his grandfather's TV, turn it on and do the video conferencing with his grandfather, and then he can turn everything off. It's no problem. And I just copied it to use it on my cat. So there's tons of projects you can do, and I have found out everything I think about, I want to try, I want to do, somebody already did it. So if you find something, you Google it, you'll find a solution. Somebody already have an answer for that. This is pretty much all I have for today. Anything you guys want to talk about?
I don't have any questions.
We will meet again in 2 days about the labs. Okay. It's optional, so if you have questions, just come over. Hopefully, I will be there also. Hopefully, I know how to solve the problem. Mostly, I don't know how to solve your problem, and we can do a research, Google it.
I actually have a question.
Yes.
How do I start up a downloaded file that I downloaded?
How do you
Like how do I start a downloaded file?
start a downloaded file?
Yeah. Here I can show you. I'll show
You
you.
mean an executable file? You download a.
Are you trying to find a downloader file?
Yeah, and then just start it. Oh, okay, so here, I'll show you.
You go to download folder. It will be there.
Yeah, but it doesn't show up in there.
It had to be finished downloading.
Well, I mean, it did download it, but then I don't know where it is then, if it's not in the downloaded file.
Oh.
Uh,
Then you might check the setup of your web browser. It will point. You may point to a different location.
no, I didn't download it in the web browser. I downloaded it from like the let's see, like there's like this library where you can add, software and stuff. Here, I'll just show you.
Yeah.
Yeah, show us.
Let me open the. Okay, share the screen. Show us. Yeah.
Yeah. Shots.
All right, so you see that? You see it now?
Yeah. Yes.
Okay. So this is where I downloaded. So I went to I was looking for the benchmark, right?
Oh, okay.
All right, just a minute. And then so I downloaded this hard drive
Oh.
benchmark.
Okay.
Okay, so now where is it now? So I can start it.
It's installed automatically, so it's already executable. You can just run it. You don't need to reinstall. It's already installed.
Oh, okay.
If there's a check mark over there, it's already
Yeah.
there. You just run it on your terminal.
Oh, so then do I just say that name and just run it? I mean, like,
Yeah, you may Google it how to run this. Find a little bit information about it, and open up a terminal and run that command. That command is already installed.
oh, okay.
Everything on that package is already installed in the right folder.
Huh, okay.
So it's do it for you already. So that's why you have this graphic interface. You can do it on the terminal also, but most people like graphic interface because it makes your life much easier.
Right. And then,
All right. Yeah.
Well, and then what about these required packages? Do I need to download these too?
Yeah, you have to download all the required packages. Otherwise, it will not run.
Maybe that's why.
Yeah. So you download everything. Yeah.
Okay. Well, I mean, yeah, you can download a lot of stuff in here, like you said.
That's right. That's right. There are millions of.
Like, you can download more games.
Yeah.
What if you just clicked apply? Like when you hit that one, you just hit apply.
Yeah, so I guess you would apply it like right here. But then.
Oh, or you can install.
Yeah, and you can install all these games and.
Right click install.
Yes. The reason you can do all this is because on this system, every application came with the C source code. So once you complete the system, you just recompile and you get it executable. So it's easy, very easy to port all the applications to a new Raspberry Pi platform.
Oh, okay.
I actually recompiled some applications myself. You can recompile just using Raspberry Pi. You can also something called cross compile. Cross compile means you compile it on your desktop. Hopefully, you can compile much faster. And then after you compile on your desktop, you download it to your Raspberry Pi and run it over there.
Oh, okay.
everything you see, including the operating system, came with the source code. So there's unlimited resources over here. You can study the source code. You can become, if you spend enough time, you can make your own contributions and make it official distribution. Part of the official distribution. If your version is accepted by the community, there's a community for everything.
Yeah. Well, then that's it for me. Then I'll just have to look it up how to
use that package. Yes.
Okay, and then download
some of the packages maybe has a graphic interface. All you need to do after installation is go through the menu, clicking your way to that package. So right. if it has a graphic interface, it's automatically on the menu.
Go to your menu and go to accessories and see if it put it.
That's right. Yes.
If I can get out. It's okay. If I can.
Oh, you already ran that?
What?
You already ran? Oh, Task Manager. Oh, it's not benchmark. I was thinking you are running a benchmark right now.
No, I'm gonna end it.
Dude, you broke your Raspberry Pi already.
I did. Oof.
Well, the more time you spend on this, the more you don't know, because you will find out so much you want to know, and it's a good and it's time well spent, because you will get more knowledgeable. Because this platform is the most common computer platform.
Right. I thought I ended it. She won't end. Okay, yeah. I guess I'll just have to wait until it downloads and get out.
Yeah, it may take a while, because the code itself may be small, but the required package may take a longer time. Depend on dependencies. So that's what Unix does. It has dependencies. If your code require a certain package and that package require another package, so they have to load up everything based on dependencies.
So there's a big file then.
There you go.
Cancel. So what did you say?
I would say look in accessories. Or what's that, universal access? Because I don't have that on mine. Oh. See if it added it in any of those menus.
Well, I already checked actually.
Oh.
Maybe they don't have a graphic interface, so you have to open up a terminal to run that package.
Okay.
Yeah.
Well, and I still have to download those other files too.
Yeah.
Okay. I think I might do that then. All right. How do I get out of here? Oh, here we go.
Great. Everybody learned something. Anybody else?
Yep. We learned not to download the benchmark.
Perfect.
Yeah.
All right. I'll see you guys tomorrow.
Yeah.
Day after tomorrow.
All right.
All right.
We'll see you tomorrow too.
Yeah.
What? The lab for tomorrow is Zoom?
Yes.
Okay. All righty.
For tomorrow or Thursday?
Both.
They were talking another class. Yeah.
Different class tomorrow.
Oh.
All right.
All right.